Hi folks, in this video I'll demonstrate some basic use cases of containers. So first off, let me just go over what we intend to do um, pictorially so that when we do it with the VS Code, it makes sense what we're doing. So imagine this is our physical machine, also known as the host. And in the internet somewhere, kind of like how GitHub lives in the cloud as a service in the internet. So does Docker Hub. And Docker Hub provides a way to store container images, right? Usually just called images. And you can think of them as blueprints. If we go back to our analogy of the house building, a blueprint is the instructions on how to build a house, but it's not the real house. So analogously, images are instructions on how to build and run containers, but it's not real containers. Another way to think about it is maybe you can have files, right? You work with files, and then you open them up in the actual application, such as Word, right? You have a Word file that you can save and pass along, and then when you run it in Word is when you actually use it. So very kind of similar, but I think blueprints and houses make more sense. So these images is our blueprints. Docker Hub is a place where people collaboratively work on and share images. Each box will represent an image. So the first thing we're going to do is kind of download an image from Docker Hub onto our host system, sort of like cloning, and we can down multiple ones. So that will be what we will call polling an image, similar to git pull. And then we're going to use an image and then run an image, which then creates the actual container. Okay. So then when we can run multiple containers, we can have one image be used more than one time. Right, one image can have multiple of these containers, or we can have one image run a container and another image run another container. That's all feasible. But for us, for our learning and development, we're just going to run one container. And then we'll have our browser. So we'll use a web browser. Oops. Try that again. Browser. And this could be our Chrome, Firefox, Safari, Edge, right, depending on which operating system you're on. And we're going to have the browser reach kind of like a request a web server from the container. And the container we're going to run is Nginx. So Nginx is a web server that's that's purpose is to serve our websites. So we're going to have this web browser request a web page from Nginx, and Nginx is going to return the web page back to the browser so we can see it in the browser. And that's how we can know that we can know that the container is running and working as we expect. Okay, so that's what we're trying to do. Okay, so in our VS Code, there is a Docker extension that you can install. And when you do, it will give you this interface and list out whatever images is on your computer and any containers that's running. So there are other graphical interfaces that give you awareness of what's happening on your machine relative to containers and images. But for this class, we're just going to stick with VS Code and use these extensions within VS Code. Okay, so here we're going to use the command line. So let's see, make sure Docker engine is working. Our command line is able to connect to Docker. That's the engine that's running on a host. So now let's do this first part of pulling down an image from Docker Hub. And another resource that's useful is Docker Hub's website. So here, if we search for Nginx, I like to use these Docker official images. They're maintained and in good standing because anyone can upload images on here, so it's good to use something reputable. So in here, there's usually a README on how to use these containers. And there's usually a link to Docker file, which is the instructions to build these containers. And we'll go over how to use Docker files a little bit later. So for now, we are going to just pull down this image. And so to pull it, we use this command, docker pull nginx. And here, we'll notice there's no images, no nginx image on the machine. And if we're to check that, we can, from the command line, we can do docker images, and it'll show that that's all there is. Okay, so now let's pull our nginx image. And here you'll see the first kind of characteristic of containers is each one of these lines is a layer. So you can think of an image as a cake. Each layer is something changing in the file system of the image/container. And that's can be represented by here. Each one of these instructions is adding or modifying something on the file system. So each one is going to create a layer of modification in the actual container/image. And the beauty of some of these containers is that you can share. So you can go from one image, add your own custom instructions, and then create another image. So your image and someone else's image using the same Debian Bullseye image can share certain layers. Your cake will, the bottommost layers will be identical. So that helps in moving these image files around, because if you can just pull down the layers that's changed, then you can kind of reuse what's already been downloaded. So that's a nice feature. So here we see that the download is complete, the pull is complete. We see our Nginx. Tags is kind of like versioning for images. So here we see that the latest tag is this version 121. And latest doesn't mean always what's latest. It's a name, so latest could be attached to another version that's earlier on. It doesn't mean the latest release version. It might be more related to the latest one that's been uploaded. So be careful of that terminology there. Okay, so now that we have our image, so we wanted to specify another image, we could do 121, but for now we're just gonna use the latest. Okay, so that means we've pulled down our image, and now we're gonna try and run this. Okay, so before we run, we'll use the ps command to see which is running, which is what's shown here in the graphical user interface. But command line, we can also check out what's running in the command line. Okay, and to run it, they normally give you instructions. Okay, so D is kind of running in the background. I'll explain that in a bit. So we do docker run nginx. It'll run our container. So the triangle play means is running. And you notice that I've lost control of the command terminal. But if I press Control C, I'll get it back. But that also means I've stopped the container. So that's what this D is for. Docker run -help -help. So it's this detached. So if we were to do it again, docker run nginx detach nginx, it'll start up another container and it'll run it, but it'll give us back our terminal, so we can still use it. So that's what that is. Here you can specify a name. So we do docker ps. It'll show that one container is running. It doesn't show the stopped one unless we do docker ps show all of it, and we'll know that one of them is exited. So here, Docker gives us nice names that we can remember, easier to remember and type out, as opposed to using these IDs. But if we wanted to specify our own name, we can pass in this name parameter. So we do docker run name container demo. Let's do detach, and then run nginx. I'll create a third one with the container demo name. And if we want to see the one that's turned off, we can see all three. Okay, so that is the actual container. So we've done this part. We've took our image and started up a container. Okay, so the next part we're going to try to do is see this web server, web page that this Nginx is serving. And then before we do this, let's clean this up here. So the containers are like computers. We can stop them. So we're gonna shut them down. We're gonna say stop. Let's do sys, or we're gonna stop this one here. And that should show up here as stopped. And we can also use the GUI and say stop. So again, maybe we use PS. They're all exited. So that's all stopped. So stopping a container is equivalent to shutting down. We can actually destroy it. We can say docker remove, again, suspicious SHA. And if we're to list it out again, suspicious stall is gone. So removing is equivalent to throwing your computer away. So stop is to shut down. Remove is throwing your computer away, essentially destroying it. And we can do it from the GUI as well. So we can remove that. And remove that. And if we try list it out, they're all gone. Okay, so now let's rerun this container and actually use a web browser to interact with it. So to do that, we have to expose a port. So all these web pages, they're running on a port. HTTPS by default is 443, but they just but it's so common the browsers kind of hide it from you. And HTTP will be port 80, which is very conventional. So that's the port that this container is listing on, and that is configured here. And each container can listen on any port they choose. This one's going to be on port 80. So let's do that. Let's do docker run. And this time we're not going to detach it. And this time we're going to expose our port 80. I think Docker really wants just P. Docker run. Interesting. Oh. Oh, here it is. Yeah. It's not port, but publish. It's the long version of the syntax. Okay, so here we're running it, and I'm Control C to stop it. Okay, so we can't start it up again. We have to remove it. Or we can't use run because it'll try to spin up another one using the same container name. So we can do docker start. I'm guessing we can say the container name. So docker start container demo, and it'll start it back up. And this time it's running in the background. Okay, so that's essentially turning your computer back on. So if we do a ps all, we can see that the container port is being exposed, and this is the host port. So 50757. So now if we were to go to local host 50757, we'll see the Nginx splash page. So here we can see that we're interacting with it. So now let's talk a little bit about this 50757. On our host machine, we have networking. And the containers port that is listing on is port 80. But the browser cannot reach straight into container. It needs to go through this network on your host machine to get to the container. So the localhost network, which is the networking in your computer, is going to take this 50757, and so what ends up happening is we're not going direct to the container. We're going to the localhost 50757 that then gets rerouted to the container, and then the container responds back through that networking to your browser. Okay, but this 50757 is auto-generated by the Docker engine. So we were to stop and start this back up and check which port is routed now. It's a different port, 5774. So that's what this extra portion is for us to specify which host port we want to forward to our container port. So what we're going to do is use 8080, which is kind of conventional. So we're going to not use this 757, and instead we're going to use port 8080. Okay, so let's do that. So we can stop our container demo container. We might have to destroy it. I wonder, because start, I don't know if start allows us to specify the ports. Yeah. So let's remove it as well. Here it's removed. And now let's do Docker run. And we're going to say forward the local host 8080 port to the container port 80. So here's running. And I'm sure in this somewhere we'll see the ports, hopefully. So here we see that it is, those settings are being set, but that's interesting. I've never really used that feature before. Okay, so if we go back here and refresh, when we go to localhost port 5757, it's nothing's using it and responding to it, so we now have to go to localhost. And if we were to stop it, so Control C, because it's attached, we can stop the container, and if we refresh, nothing's listening, and it'll respond with nothing. So that's some basic usage of containers. I'm gonna go through one more cleanup, and so we can actually remove this image as well, not just the containers. So let's start by removing the stop container. And if we do images, see our Nginx, we can say image, and we can use this remove. So there's also a way to push your images to Docker Hub if you have an account there, which is free. So image remove Nginx. So here Nginx is deleted. And to do the same thing, let's pull it back down. I think we can also do it from the web this VS Code interface. Okay, so again, it's downloaded. Okay, so you have to delete by the tag. So we remove this tag, and there's no more Nginx images. So we verify images, it's gone. And the last thing I want to say is about this networking. This local host is local to the host. Um, is in the context of the host. If you were in the container doing activities, if you were to try to do anything localhost, it'll be in the context of the container. So that's something to be aware of. And there's other interfaces like 0.0.0.0 and 127.0.0.1. And they all have different nuances. I know for containers, if you're running a server here, you should be listening to the 0.0.0.0 interface because when it's routed from the host, it comes in, and when you're the container, it's not really localhost, it's 0.0.0.0. So those are some networking nuances. We might not encounter it, but if you do see something like that, that's the reason why. Okay, so in this video, we showed how to pull down an image from Docker Hub, convert an image to a container, and then use a browser to interact with the running container. We also showed how to start, stop containers, and remove containers. So shutting down, starting up like your machine, or throwing your machine out the window, destroying it. And we also demonstrated how to clean up images by removing them from your host machine as well. Hope you enjoyed it and you're starting to see some use cases or how images and containers are used. Thank you for watching.